Good? Okay. So yesterday we really quickly went through multiplication models, but there were enough people in this class and the morning class that I thought I should go through each one specifically. Also in your packets, and I'll grab those right now, about 75% of people still use, basically I'm going to call it the in your head model as one of your two choices. Okay? So a reminder, with each one of these, and this one is actually a good example of what to do, with each one of these questions you need to go through and you have to give me two separate ways in which you answer the problem. One of them cannot be in your head, so don't just write a number down. Also, for these questions, since they're simple, I know they're simple, don't just write 7 times 3 equals 21. Okay? That's basically doing it in your head. That's not repeat addition. That's not modeling it. So don't do those for these questions because they're very easy. Later in the packet, when I have you do sheets, then you can start using that method because you're actually carrying numbers you have to worry about place value. Cal?
Like I did like the answer, I wrote it on the side. Is that okay? And then I do 2 ways. Yeah.
Yeah, you can write, okay, so you're saying like if it's 7 times 3 you wrote 21 and then you showed 2 ways that you got to 21?
Yeah.
Yes, that's fine. Because basically that's showing me that you can do it in your head and 2 ways, that would be 3 ways. Was there another question or was it the same thing? Okay, so when you get your packets back today, which is going to be in a little while, please look through it. I didn't mark any wrong. I just looked through them very quickly to see how people are doing. Change them if you don't have 2 separate ways. Okay? So, the different models, we'll fly through these pretty quickly. First of all, you have the picture method. We talked about it yesterday. You're only going to use this for smaller numbers. You're not going to use it for large numbers, otherwise it would take way too long to do. So if you had 2 numbers that are over, or that are 2 digits or higher long, don't choose to do this method. This method is if one number is a single digit and the other is a single digit or a low 2-digit number. So the example I use is Susie's making 4 cookies for each classmate. She has 10 classmates. How many cookies does she have to make? I made 10 cake pans, and the lines stand for a cookie. Okay, so it's a picture model. So there's 10 cake pans, 4 on each. What's the answer? 40. Okay, you can do that in your head, right? Is there anyone in here that didn't feel like they could do that in their head? Okay, I can't either. So I know that you can do this in your head. So instead, draw a picture. That's one of your options for the small numbers. The second one is an array. Just so you know, this is accessible on the website, so you can look through these. So the array is going to be used again for small numbers. You don't want to be drawing forever. Okay, even making an array this large took me a couple minutes because I had to find the picture, I had to copy and paste it. You don't want to go much larger than single-digit numbers. Okay, maybe up to 24. So if you have a 6 times 4, maybe up to 30, somewhere in there. But that's even getting to be a lot of items that you're drawing or you're copying and pasting. So for arrays, you're usually going to have very small numbers. So the example I use is Jake has 4 pencils, Marissa has 3 times as many as Jake. How many pencils does Marissa have? The array itself would be that Jake has 4 pencils, and she has 3 sets of those. Therefore, she has how many?
12.
Very good. Not very good. All right, the next one, you also know this one, repeat addition, and this I saw a lot in the packet. This is good. Try to practice other ways if you're good at repeat addition, though, especially with small numbers. But repeat addition can be used for larger numbers as well. Just if you have 2 2-digit numbers or greater, be wary because if it's 28 times 28, you don't want to add 28 different times. That's a lot of adding. So that's going to end up taking a while. So usually it's going to be if you have a large number and then a small number together. So you're going to add the large number a small number of times. So the example I use for this one is there are 28 students in each class at STEM. There are 6 classes on our floor. How many students are there in total? So I added 28 6 times and got 168.
Is that accurate?
It should be accurate. I did it in my head, but it should be accurate.
You have 28 each class.
Yeah, it's supposed to be 28 in each class unless someone left. There can never be more than 28. So this would be technically accurate.
Really?
Yep.
Because
All right, the next one. This one you might not know so well, and this is one that I would suggest practicing with smaller numbers, or if there's a number that says maybe 12 and 8. It's anchor facts. So the facts that you already know, you can use addition, subtraction, multiplication, division for these. Okay, so breaking numbers into smaller numbers to make it easier for you to do. And these anchor facts you should be able to do in your head. So, You can use this for large numbers, you can use this for very large numbers, you can use this for pretty small numbers. Alright? The example I had, the first one, John eats 8 cookies for 12 days straight. So some of you probably know what 8 times 12 is. I'm not going to question that. Many of you probably do. But for someone who doesn't, you could look at it, and so you're looking at how many can John eat. You're going to say, well, 12 is close to 10, so let's go 8 times 10, which is 80. And then I know that I have 2 days left, and each day eats 2, so it's 2 times 8. So I'm adding 8 times 10 plus 8 times 2, and that equals 96. Does that make sense? Oh, it should be equals. That's fine. Yes?
So it's like simple multiplication?
You're changing tough multiplication to simpler multiplication. The second one is an example of how you could use larger numbers. So if Steve runs 26 miles, so just less than a marathon, at an 11-minute mile pace, how many minutes did he run for? I know that 26 is close to 25, and 11 is close to 10. So I went 25 times 10, which is 250. You should know that in your head, base 10. Then I knew that there was one extra 25, so there was 1 minute left because I made that 10, and I was going by 25, so 1 times 25 is 25. And then since I lost 11 minutes here, so there's 1 extra on this side, and there are 11 on this side, I went 1 times 11. It is, that's why you need to practice it. To me it makes a lot of sense, to some of you it might make a lot of sense, but to some it doesn't. Then you add those numbers together, and the total is 286. So I did that without a calculator, I did that without writing down everything, I just broke it down into different layers.
In your head?
Okay?
Cool.
Yep, so I was able to do that in my head because I was able to break these down, this down into these.
So these are all ways that you can do it in your head.
So you can do the math in your head, right? But you're going to show me what you did by doing something like this. Okay? Right. Okay, so anchor facts is another way. That's a way that I would suggest practicing if there is a number that's going to be more like 8 times 12. In this packet there are 1 or 2 of them on the first 2 pages that are like that. Those are opportunities to practice that. Yes?
So for the packet, like if you didn't finish yesterday, if you actually finish that packet today?
The first 2 pages, and 1 page is front back, the second page is front back. So the first 2 pages have to be done by the end of the day tomorrow. Okay, do not go on. The rest of this I'm going to give you different directions for each page. Yes?
So 2 pages, front back.
Yeah.
Not just
Correct, so front back, okay? The last way, I'm going to go through this quickly. If you have individual questions, that's fine. We talked about it very quickly yesterday, is the lattice model. Okay? With this one, you can use huge numbers. Okay, so the example I give is Christy has 27 erasers, Matt has 12 times more than Christy. How many erasers does Matt have? What you do is you take the numbers, so 27 and 12, and that's going to be how many boxes there are. So let's say this number was 271. How many boxes this way would there be?
3.
There would be 3. So for every place value, you add a box. So if this number was not 27, but it was 7, how many boxes would there be?
2.
Well, you could do 0 and 7, or you could do just 7. Okay, you don't need the second box. On the other way, so the vertical axis, this number is 12, so there are 2 boxes. What if the number was 127?
3.
There'd be 3. So if this number was 270 times 127, how many boxes total would there be on the whole grid? So there are 4 with this one. If I add 2 more here, 2 more here, and then there would have to be 1 here, how many would that be? Cal?
I was just going to say something, I don't have the answer. Usually the larger numbers.
Usually it is. Makes it easier. There would be 9 boxes. So 3 digits times 3 digits, and it's a square, so 3 squared is 9. So 3 times 3. Okay? So, then what I did, and I'm going to try to kind of cover things up, but it could be confusing to you if you don't know what I'm talking about. First thing I did is I went 2 times 1, and what's the answer?
2.
So that would go here. If it was more than 10, you'd put the 1 here, and the other number here, but since it's not, you would put, there are no 10s, where do you go? There are no 10s, so you put 0 there and 2 there. Then I went 1 times 7, what's that answer?
7.
So 0, I'll I'll talk about the 1 in a moment. 0 and 7. Don't worry about the 1 right now. The 1 is up and away. Okay? It's not a part of it. It's not there yet. The next thing I did was 2 times 2 is 4. So I have a 0 and a 4. Then 7 times 2 is? So this one I have a 1 in the 10 spot and a 4 in the 1 spot. So once you have the chart filled out, you add diagonally. So within this diagonal, within this diagonal, within this diagonal. And you're going to start always from the 1's column. Okay? How many are in this diagonal?
4.
So I put a 4 here. How many are in this column?
12.
So I put a 2 in this column, and just like in normal addition, I carry the 1 over to my next column. So now, how many are in this column total? 3. So my answer would be?
4.
324.
324.
That's a lot of your erasers.
What's that? It is a lot of erasers. But I went to Action Territory this summer, and I got 600 erasers with the tickets I won.
Oh, that is.
These little ones.
Oh,
Yes.
oh.
Okay. Are there any other questions? So does everyone understand all the different opportunities they have to do some of these?
Yes.
Okay, this is on the website under its own tab.
It's a
Sam, you can close it or hit end. The tab is